Hello everyone, welcome back to HSC. This is me, Jaewon Shim, presenting Bluetooth controlled cars using Arduino in the second part. So you guys have already watched part 1 of this series, and at the very end of part 1, remember that I was going to show you a video that follows the schematic, right? So in this video, we are going to do this. So let's get started. Here I've got these two chassis, and I'll tear up the sheets for each of the chassis. So let's attach and assemble all these pieces together. Now our final step is to assemble the wheels into this 4WD car chassis. So here are my 4 wheels, and I'm going to plug in one of the wheels right here. And then plug in the rest of the wheels into the car. Here's what the finished product of this 4WD car chassis look like. And yay, we're done! Now let's start into the code for this project. Hashtag include new ping.h. This new ping library here enables the cars to avoid obstacles in their ways. Then we're going to also type in hashtag include servo.h. And you should be familiar with this library as well. Now, follow along to the next tab. Hashtag define trig pin A4. Hashtag define echo pin A5. Hashtag define max distance 200. New ping sonar, and then trig pin, comma echo pin, comma max distance. And last of initialization, servo my servo. Boolean goes forward equals false. The reason why I want to go forward as false is so that, like, when you run this program, the car stops moving. We also want to know the distance the car traveled, so we're going to type in int distance and initialize that to 100. And then int speed set equals 0. We need the speed set to be equal to 0 so that the car stops moving. We're going to type in const int motor pin 1 equals 11 and const int motor pin 2 and set that variable equal to 10. So these are going to be the motor variables for motor A. And next off we have motor B. So we're going to type in const int motor pin 3 and set that variable to 6. Const int motor pin 4 equals 5. So those are going to be the pin values for motor B. Then we are going to create a method called void setup. Here inside the void setup method, we're going to type in myservo.attach 9, myservo.write 11, whoopsies, 115, sorry. And then we write delay 2000 distance equals read ping, and then add another delay method and set that timer to 100 milliseconds. And then we reinitialize distance into read ping so that it keeps like reading the pin after this amount of milliseconds. And then add another delay for 100 milliseconds, and then another distance equals read ping, and then we end off with delay for 100 milliseconds. Now let's add another method, and we are going to create void loop method. So we want to create the two variables, one for the distance the car moved to the right and the distance the car moved to the left. Sorry. So we are going to write int distance, uppercase R. This variable denotes the amount of distance the car moves to the right. And let's set that variable equal to 0. And another variable is int distance L, and let's set that variable equal to 0. Add a delay for 40 milliseconds. If distance is less than or equal to 20, move stop. So basically this method will stop the car while the thread goes through this code of block. So that means that the car could stop after it finishes moving. And let's set that delay timer to 100 milliseconds. Then we add the move backward. Meaning the car would literally move backwards as you control it with this code. Now we delay this time for 300 milliseconds. Another move stop. Delay for 200 seconds. Distance R is now equal to look right. And by the way, we're going to make this method later in this video. So keep following along. Now I'll show you in about a minute later. And then add another delay for 200 seconds. Distance L now equals to look left. Same reason for why I'm going to create this method after one if block. Again, delay for 200 seconds. So now, if distance right is greater than or equal to distance left, then you would have to turn right. And then you move stop. Else, you would have to turn left and then move stop. Or else the car would keep going if you don't make it stop. If the distance to the left is neither greater than or less than distance R, or if they're equal to each other, then we put the else condition, and then we just move forward. And then the distance would equal read ping, and this read ping method reads the current distance that you're at, where the car is at. Okay, now let's dive into the int look right method. So inside look right, you want to add myServo.write 50, delay for 500 seconds. Delay for 500 milliseconds. And initialize this variable called int distance equals read ping. And then add a delay for 100 milliseconds. myServo.write 115. And then return distance. Now it's the same for, I would say, look left, but I'm going to change a few variables. But before that, I'm going to copy and paste that method. This is look left, and then instead of 50, we do 170. Keep these variables because they're basically the same thing. And also keep this value too. But then it's a little different. After you return the distance, you would have to delay and add another delay for 100 seconds. Oh, whoopsies. we're gonna also focus on the last two methods, which are read ping and move stop. Now let's create int read ping, and in this method, we add a delay for 70 milliseconds. Int centimeters, or cm, equals sonar.ping cm. If the centimeter is equal to 0, then the length in centimeters would be equal to 250. And then you return that value. And finally, we're going to move on to void move stop. And we start with analog write, motor pin 1, comma 0. I'm going to copy and paste this 3 times. And I'll change that to motor pin 2, motor pin 3, motor pin 4. Also, don't forget to add move forward, void move forward. And then we do analog write, motor pin 1, 180, let's say degrees, because that's the value. Then analog write, motor pin 2, 0, analog, and then analog write, motor pin 3, 180. And lastly, analog write, motor pin 4, whoopsies, 0. And finally, the move, and we are going to add the move backward method. Oopsies. And then we're on to the move backward method. I'm going to copy, paste this last method, and switch this duplicate name of move forward into move backwards. And I'm going to change this a bit, change the values for all of them a bit. Instead of 180, it's 0, 0 to 180, etc. Now we're going to create the void turn right method. And analog write, motor pin 1. Starting from the first motor pin, you'll be at 180 degrees. Analog write, motor pin 2, 0. There. But we also have to add like a delay for 300 milliseconds. And then move forward. Woohoo, we also have the turn left method. Last but not least. So go ahead and type in void turn left. Analog write, motor pin 1, 0. Analog write, motor pin 2, 180. Analog write, motor pin 3, 180. Analog write, motor pin 4, 0. Add a delay for 300 milliseconds. Then you move forward. Yay! I hope that this code works if you try to run it into your computer. Here you could see this nicely well-built model of this project. And here you can see these wires, the red and black ones, have been soldered into this what's called TT gear motor, or the yellow motor. So I did this in all 4 motors, like tightly wrapped and nutted. I don't know if that's the right word, but yeah. I assembled all these pieces together. Now all I just need to do is to put this top chassis onto Thank you for watching. Oh, you forgot one more thing. You have to put the blue controller, as I mentioned in the first part of this video, or at least the series, which is called the Arduino Bluetooth car. So you need that in order to power your car. And you also need the battery holder and connect those with the Bluetooth module as well, because we're going to use that for Bluetooth to control the car. So if you don't put any of those, then how will the car move? It will not move at all. It's just like saying, without a human brain, the human will not be able to move or function properly, right? So it's the same for the car. But anyways, I will do that in the next video, which is part 3 of Arduino Bluetooth controlled car. See you in the next video.